This is the FM Gold channel of All India Radio. In the program News Analysis, we now bring you a discussion on India's mission to Mars. The participants are Professor P.K. Mukherjee, Professor of Astrophysics, Delhi University, and Dinesh Chandra Sharma, Science Writer.
The Indian Space Research Organization today added another feather to its cap with the successful launch of the Mars Orbiter mission, which is popularly being called Mangalyaan, which is India's first mission, which is interplanetary. That is, ISRO as a space agency is trying to reach out to another planet. So far we were only having satellites which would go around the Earth, or we had Chandrayaan which went to the moon, which is satellite of the Earth. But this is the first time we have had a satellite, an orbiter which is going to go away from the gravitational influence and go to another planet, and it's a long journey. So I think it's quite a remarkable achievement, though we can only say that the first part has been successful in the sense the launch has been successful and orbiter has been established in an elliptical orbit. And it's a long way to go, because as we know that mission to Mars is quite a long journey. So Professor Mukherjee, I'm sure there are many more hurdles before we reach the Mars orbit as such.
In fact, with the launching of a Mars orbiter today, it has started its mission, no doubt, but it is a 300 days long odyssey, and this distance is also long, around 780 million kilometers to Mars, and it will be reaching, in fact, on 24th of September next year, that is 2014. In fact, after the starting of this journey, in the wee hours of December 1, it will in fact start this journey. Until then, it will be in the elliptical orbit around the Earth, and before that also, with the help of the boosters, it will be placed in higher orbit. And then onwards, from December 1 onwards, it will start the actual journey to Mars.
So I think there is a lot of confusion among the minds of people that why go to Mars and what is the real objective of this mission. I think we can look at it this way, that people are asking that when landers have landed, like Curiosity has landed on Mars and they are sending data on Earth very often, and we know exactly how it looks like, and there's a lot of imagery of Mars, and why should India send a mission to Mars at this stage? But I think that the answer to that would be that as a spacefaring nation, as an independent space research organization, ISRO wants to establish its presence in the deep space, because I think it's more of a technology mission. We would say that we want to demonstrate to the world that we have a technology to send a man-made object 400 million kilometers away, monitor it from the constantly and get data, and all the maneuvers have to be taken there. So I think there is a lot of technology enhancement required. And unlike Chandrayaan, because naturally in the popular mind there are comparisons with Chandrayaan, but technologically speaking there is no comparison between the two missions, I think.
Yeah, in fact the Chandrayaan mission, of course, used PSLV, which is the workhorse of ISRO. This time they are using PSLV C5, and which is the proven technology. And this is one great thing about India's space mission. But here, as you said, Mr. Dinesh Sharma, that there are a lot more things from the point of view not only technology but science also. And of course, it is a great achievement on the part of India that in the maiden attempt it succeeded, whereas most of the nations, there was in fact till date about 45 odd missions have taken place. Of this, one-third have met with failure. And even the latest mission in 2001 of China failed. And before that, prior to that, Japan's maiden mission also failed. So that way it is a great success. That is feather in the cap.
I would beg to differ a little here, because of course the launch has been successful, because I think the maneuvers which have to take place, as you rightly said, that first it has to go around an elliptical orbit around the Earth, and on the night on November 30th and December 1st it would be put into a trajectory towards the Mars, and that part is going to take the longest, and then the final maneuver takes place to put the orbiter around an orbit in the Mars. So that will be the final destination. But I think each of these maneuvers, the number of maneuvers would be carried out during November, and then on November 30th this maneuver on a trajectory to the Mars. I think all of them are very critical, because these are all new areas. When some of the configurations of these orbits were never tried even for Chandrayaan. So I think they are very critical. So it would be not premature to say that it's been successful, but launch has been, takeoff has been successful, launch is successful, the orbiter is in an orbit around Earth, but more things need to be done, which I think are equally critical. Many missions have lost their way on this long trajectory of millions of kilometers.
Everybody knows in this space is high precision work, and therefore, of course, launch has been successful, but we have to keep our fingers crossed, and we have to hope for the best that the maneuvers, as you said, that maneuvers also take place accordingly. And finally, it is put orbiting the Mars, and at a distance of, say, nearest is 385 kilometers, and farthest one is 80,000 kilometers. So we have to hope for the best, and with the ISRO doing good work, and with PSLV as our established as the workhorse of ISRO, let us hope that maneuvers will be taking place successfully in days to come. We have to watch out.
It's a grueling journey because there are all kinds of radiation, temperature changes, the materials which are used in the satellite have to withstand, the solar panels have to perform as planned.
So many problems
the
in space.
Fuel part of it has to, although it will be just coasting towards the Mars and fuel use would be much less, but still I suppose there are a lot of ifs and buts. But it's certainly a good beginning.
But then one question, that is generally asked, we have spent around 450 crores in this mission. Then how we are going to benefit it as a nation and as a citizen of this nation? This question is often asked.
See, it's a very simple thing to say that why waste this kind of money? I've been reading in some newspapers and even some former officials of ISRO said that why waste rupees 450 crore? But you have to look at the space program in totality. I'm sure you will agree that what all the missions which ISRO has on its table. On one hand, you have the operational satellites, you have INSAT, you have METSAT, you have CARTOSAT, you have a number of operational satellites from remote sensing to cartography to ocean monitoring to megatropics. We have a whole range of satellites. So that is the operational part of it, and the other one is the science part of it, because ISRO as a space agency, space research organization has to investigate further into space. So after Chandrayaan, which had a very good success despite the fact that time life of the mission had to be cut short by 1 year. It was planned for 2 years, but we had to cut it down to 1 year. But within that 1 year itself, it could do a lot. And as we know, it discovered the presence of water molecules on the moon. So the science part of it also is very important. Although compared to Chandrayaan, the science part here is much smaller because the number of payloads is much smaller, and the weight, just 15 kgs, it was 100 plus kg in Chandrayaan.
I would like to say that what is the number of payloads? 5 payloads have been sent. And the purpose is to make atmospheric study as well as surface imaging study, and then this particle environment studies. And then there's color camera also there. And there are 3 more instruments on board. As you said, total payload is 15 kg. Right? Then what are the things we are going to study and what is the outcome? How much it has been studied? How we are going to benefit?
I don't think there can be any direct benefits as such. But the thing is that, it's more of a technology mission and less of a science if you look at the payloads as such. Because if you have heavier payload, they have better precision and, we are able to get more data for longer, or maybe resolution is higher, and all those issues are there. But the methane sensor is being suggested as a key payload because presence of methane, I think, is an indication of life, so to say, on Mars.
Not only life, but also geological processes, both biological and geological. We hope that there would be life in the form of microbes on Mars, but it could be geological reasons also. Mineralogy is also there, due to that also methane. So purpose can be twofold. And in fact, there is one thing that when 4.5 billion years ago, when solar system evolved, then Earth, Mars and Venus, they originated at the same time. But the conditions in Venus and Mars became uncongenial for life, whereas for Earth remained congenial. So what could be the reason? And in fact, from the study of Mars, because these days we hear so much about the global warming, climate change, etc. So what lessons can be learned from the study of Mars? I think that will be an interesting
that will be an interesting question to address. But I don't know whether this mission can really address such larger issues because it's just the beginning. You need a long-term data. Of course, you have data from Curiosity, the landers and rovers, but only mineralogical mapper may not have much of in-depth data. But there is one advantage between landers and rovers and an orbiter. That's what I understand. Because an orbiter can cover a lot more number of areas on any body. Like Chandrayaan also could go around the moon in a number of orbits or a number of times. So it could generate more data. And whereas a lander would be confined to a particular area. So that is the reason earlier missions to the moon could not discover the presence of water molecules on Earth. So that way, hopefully, this orbiter could also be in a position to gather more data compared to maybe landers. But of course, landers are able to do more sophisticated work, analyze, actually physically they can take samples and analyze and send back the data. But in terms of mapping, maybe orbiter is a better option. And who knows, there could be some surprises
in store. In fact, this is the orbiter mission. After that, if it becomes successful, manned mission may be sent. But ISRO has the plans of sending other missions also, like Chandrayaan 2.
Yes, I think it's a
2016
continuing process.
And then Aditya for study of the solar corona. So it is a continuing process, and much depends on the outcome of this mission, because it will be not only a moral booster for India, but technological demonstrator, as you also said in the beginning.
I think in the space game or industry, if you look at it, there are very few players, and India is prominent ones there. Although our budget is much lower than say NASA or European Space Agency, but we are able to compete with them, but we are on a good footing with them. Like even Chandrayaan, they were in fact collaborating with us. So these are difficult missions, the interplanetary missions. Although other countries like China may have a different goal. They were first sent the manned mission, whereas manned mission on the Indian space program is slightly not on radar right now, although it's at a planning stage, but as we know, the approvals have not yet come in. So Indian program has progressed in a very planned and step-by-step manner. We have not tried to bypass things and go straight to manned mission.
This brings us to one question, as you said. Budgetary allocation. What do you think that after this successful Mars mission, because the launching has been successful, if it becomes successful, then will India consider to increase budgetary allocation on this?
I don't think you can straight away increase the budget like that, but yes, of course, like Chandrayaan, if you look at it, the success of that mission led to a lot of technological benefits, or you can say a lot of interest in the policymakers, general public, and young people got attracted towards it. Those are, I think, benefits which can't be counted, in terms of material, or we have this particular fallout of technology. That may not be the case, but there are several ways in which such large missions can help, and hopefully Mangalyaan will also lead to a renewed interest in space in India, as we know that the interest of youngsters in science is falling. So maybe we will be able to attract, like after Chandrayaan, a lot more young people applied for posts in ISRO. So those are the kind of benefits I think one can see.
We are witnessing interest in Mars.
Yes.
Private sector also. And as we have read, Mars 1 sending 2 men and 2 women by 2023.
Yes.
Right? So it shows that there is interest in Mars for obvious reasons. But one thing, this interest, okay, but about the PSLV, this is XL, the extra large.
Yes.
And how it is different from the other versions? Because one is the standard one, is core alone one, and it has got more boosters. Therefore, it has been used, I think Chandrayaan 1 also used it, and recently it was used on 1st of July 2013. Yeah. So, this has proved its capability. And therefore, we had, of course, high hopes. ISRO had also high hopes that it will succeed, unlike GSLV, where we have to come out
to prove our capability. Because this was the 25th launch of PSLV, which is another landmark, I think, which we are forgetting when we are talking of Mars. And out of the 25 flights, 23 have been very successful, and this is the only workhorse we have right now. This is the proven workhorse of rocket of ISRO. As you rightly said, that GSLV, we are yet to prove our capability with indigenous cryogenic engine. So I think the Indian space program with this mission has reached a landmark, although full results of it will to wait and see, but I think it's certainly a good milestone, and we can look forward to more such missions from ISRO, both scientific as well as operational, I think on
technological point of view.
Yes, absolutely. There should be a greater appreciation of these missions in general and about science in particular. I think on that note we can end today's discussion. Thank you, Professor Mukherjee.
You were listening to a discussion on India's mission to Mars. The participants were Professor P.K. Mukherjee, Professor of Astrophysics, Delhi University, and Dinesh Chandra Sharma, Science Writer. It came to you in the program News Analysis, produced and presented by the News Services Division of All India Radio. This program is also available on our website, newsonair.nic.in. You may email your opinion about this program at airnsdtalks@gmail.com.